We are continuing with the various properties of liquids. The second one we're learning about is surface tension. Now, when you have a vessel, okay, this is a liquid which is in the vessel, and there are two types of molecules that you observe. The two conditions, rather. You have the molecules in the bulk, that is in the liquid, whereas and then the ones on the surface of the liquid. So let's talk about this one first. If you remember, we had the exact same analogy, but that was for gases on the surface and the gases which are closer to the wall of the container. This, however, is going, since liquid has a specific volume, a perfect volume, or a definite volume, we'll be talking about it on the surface. So in the bulk, this particular liquid is going to have a net force and it's going to get attracted equally in all directions. However, the liquid on the surface is going to get pulled by the molecules around it. So there is a more attractive force downwards, and this leads to an imbalance in the forces, and this effect is called as surface tension. So the molecules on the surface of the liquid are under tension due to the imbalanced forces, and this effect is called as surface tension. So it's quite obvious these molecules will pull it. Okay, there's a downward force compared to this one, which has a net force, net equal force. But in this case, you have it pulling it downwards, and this imbalance of forces is called as surface tension. And the reason this happens is, the effect of this is the fact that the liquids try to minimize this particular area. It tries, because of the inward force, imbalance of this force, the surface area of the liquid is reduced as much as possible. Now, for us, if you want to increase the surface area, some amount of work has to be done. So, okay, yeah. So the surface tension is the force per unit length acting perpendicular to the tangential line drawn on the surface of the liquid, and it's represented as a gamma. And the units of this are force per unit length, that is dyne per centimeter. According to the SI system, it's Newton per meter. The surface tension of water is 72.75 into 10 to the power minus 3 newtons per meter. On the other hand, that of mercury is 47.5 into 10 to the power minus 2 Newton per meter. So yeah, obviously the surface tension of water is more than that of this one, right? Because it has 72.75. No, it is surface tension of mercury, which is higher because 10 to the power minus 2. Remember, that is also important. We can't just look at these numbers. Okay, surface tension gets affected obviously by two factors. If you remember, the same factors were discussed for the vapor pressure, nature of the liquid, temperature of the liquid. Nature will now assume if a liquid has a lot of intermolecular forces of attraction between the molecules, it will obviously make sure that the surface tension is going to be lesser, or rather, I should rather say the magnitude of the surface tension will measure, is going to give us the information as to how much is the attractive forces. So surface tension is actually going to be more for liquids which have a higher intermolecular force of attraction. So when the attractive forces are large, the surface tension is going to be large. So the intermolecular forces depends upon the nature of the liquid, and so that's why we have one of the reasons as nature. The second one is temperature. As we know, when temperature comes in, you have the word kinetic energy. When the excuse me, when the kinetic energy of the liquid increases, that leads to the intermolecular forces decreasing and the intermolecular spaces increasing. And so the surface tension will decrease. This is the same reason why clothes are washed more efficiently and using hot water. But right now you have good detergents which do get the job done at normal temperature. Generally, I mean, generally for very tough stains, we do use hot water, but uh, for the environment, it's better that we don't. So yeah. The next one, due to the presence of surface tension, the following things can occur. Have you noticed when you were young and you'd play with bubbles, you'd see that they're oval oval shaped this thing. So no matter what, it was always a circle, right? Not only that, when you have if this has happened, when the thermometer breaks and you see these beautiful spherical droplets of mercury on the ground wherever it broke. So no matter what, it will try and form that perfect spherical shape. So this particular spherical formation of spherical shape is actually because of the surface tension. It is said that a sphere is most one of the best shapes for that particular substance to minimize the surface area, because in this case the at all sides you have an equal amount of force acting, and it because of that it tries to minimize the surface area, as we know. And because the sphere has a minimum surface area for a given volume, liquid tends to form a sphere. Mercury droplets, as I told you, they are spherical. And what happens is, generally for glass, there's something called as glass blowing, where they try to shape the sharp edges of the glass and it naturally curves up using this method. Now, one very important thing is that due to the presence of gravity, there might be a slight distortion in the spherical shape, because there is a force that is getting acted, right? There is a force that is acting on these substances, and that's gravity. So you might not have a perfect, sphere, but in the absence of gravity, you'll have a perfect sphere. The next one is capillary action. Now you draw whenever we water the plants, right? The water we also okay, we water the plants, makes sense. The roots are going to get the water and plant is going to thrive. But in the absence of some human taking care of a plant, how does it make sure it lives? We are not going to go to the forest and pour water and stuff, right? So the thing is, there is something called as a capillary action that is taking place. So capillary action, when you have this, when a capillary tube is dipped into a liquid, it will rise. This is an example of capillary action. When you have a capillary tube, the liquid level is going to rise in the capillary tube. And this is because of the inward pull of the surface tension acting on the surface, that'll make sure that the water or the liquid is going to get pulled into the capillary tube. Another example of this is ink rising in blotting paper, or you could also say when you have lamps, you have the oil in the bottom and the wick. Or wick is first going to have some amount of oil, but even then it stays lit for a long time, and that's because of capillary action. And the last property is liquid wet things. Liquid actually spreads on the surface, and because of that, because it flows. As it flows, it leads to the process of getting those things. So with that, we're done with the concept of surface tension. Basically, surface tension, like in gases, the surface of the liquid molecules on the surface rather have some amount of imbalance in terms of force because they are pulled downwards, and this is not observed for the bulk. And this tension due to imbalance forces, this whole effect is called as surface tension. So the units of this are dyne per centimeter inverse, I'm sorry. And in terms of SI system, it's Newton per meter. And there are two factors which affect the surface tension: nature of the liquid and temperature of the liquid. More is the intermolecular force of attraction for the liquid, more is going to be its surface tension. Temperature, on the other hand, will lead to, when there is an increase in temperature, there's an increase in kinetic energy, and that in turn will lead to an decrease in the surface tension. There are three things which are happening around us because of the presence of surface tension: spherical shape of drops, because for a particular volume of liquid, the one with the least surface area is a sphere, and so liquids prefer a spherical shape, or spherical droplets or rather spherical droplets, yeah. And in the presence of gravity, the shape of the sphere might be a little off, but in the absence of gravity, you might have it as a perfect sphere. Capillary action is basically the pull. When you dip a capillary tube, the molecules get pulled into the capillary tube, and this is again due to the surface tension. Liquids wet things because of the fact that when they flow, they basically spread, and that in turn will lead to the process of wetting those things. That we're done with surface tension. In the next video, we'll be talking about the last topic of this chapter, viscosity.